Hello, this is Stef. Today we're going to compile FFmpeg. So we are merging everything. So in the latest videos, we compile libx264, libx265, libvpx, libSDL, and now we're going to compile FFmpeg in order to have all of them statically using MSVC, so the Microsoft compiler. We're going to compile, as we said, not shared, so we don't have the DLLs around. It will be a unique application. And given the fact that we have also libSDL, we can have FFplay, which can be very useful. Then after the compiling, we are going to test with some of the files that we create. Okay, we have Windows behind, ready to start. Let's get started. Windows is here, and here we have the folder we are going to work with. So this is FFmpeg build, as we've always used. We have build, installed, and sources to have the three things separate. So build, we have our compiled libraries and applications. Here on installed, we have the software and the libraries and the applications that are result of the compiling that can be used for other usages. So here on FFmpeg, we have the release versions, if you would like. So as soon as you make install or you put the command to install everything, it will be put here. And then there is the source code that is downloaded for the other software, and we're going to download now for FFmpeg. Okay, first thing to do is to open the x64 native tools command prompt for VS 2022. That is the terminal that allows us to open the software to compile our application. So in particular, CL, the MSVC compiler. We want it inside MSys. So MSys is, let's say, a GNU application, so a series of applications coming from the Unix systems that are available under Windows. So this is a thing that we already installed. We can go to our usual folder. There is a c:/msys64 msys_shell.cmd. We have another terminal that is opening. Here we go. And we make everything bigger just to be understandable. And we are navigating inside the folder of interest. So cd/d/ffmpeg build. Here we go. Good. So now we are ready to start to do everything. Once we are in the folder, the first thing we need to do is to go to the sources folder. In the sources folder, we're going to download the FFmpeg code that is available using our Git that is already installed. So git clone, and the URL is the following. So it's in the Git server from FFmpeg, and then space FFmpeg. Then it's going to clone everything. The server, just a bit of time, a bit of patience. It's quite big. And we'll wait until everything is downloaded. Okay, and now everything has been downloaded. So let's make sure there is. So on the sources, we have FFmpeg. We can go inside and we have everything as it should be. So we go up a couple of levels, and then we are going into the build folder, and we can start building FFmpeg. Before building FFmpeg, make sure that the installed libraries are all set. I mean, if you follow the previous videos, remember that in the installed folders, especially in the libraries, we changed something. So in the libx264, make sure that the package config and x264.pc has so the prefix, everything as it should be. Then the same thing for libx265 and also the names. So it accepts certain names that are quite rigid. So libx264 is like so. Then with x265 libpkgconfig, it allows this nomenclature. So with this folder, I told everything in the video, so everything should be fine as it is. Then make sure also the name of the library is the same. So you should rename it with this way, x265. The same thing with libvpx. So here there is x64. You should have vpx empty because we compiled statically inside Microsoft Windows system with the compiler Microsoft Windows. So be sure to rename the one that you want with vpx. The other will be like so. Why we have two different with different file sizes? Because this was the debug version. This is the release version. In fact, the original name was vpx-mtd, and I renamed it to vpx because FFmpeg doesn't accept anything without so that has different names. Same thing with SDL. Here we have also its own pkgconfig. So under lib, we have pkgconfig SDL2. So everything is fine here. We didn't change anything. So as you can see, okay, there is the name of the folder and everything with the prefix. So I wouldn't touch anything inside here. The only thing that we need to touch, since I've just compiled it again in debug mode, it's not necessary because we're not debugging SDL by itself. But if you would like to have everything in debug, make sure to remove the D here for both. So I guess that it only accepts SDL2 static, but just to be sure, I will put also SDL2 main. And now we are ready to rock and roll. Before starting with the big command, we are going to create a folder called FFmpeg, and we make sure that it's there along with the other folders. What we want to do now is to put the so-called big command, so the one that makes us the configuration for the whole thing, for the whole FFmpeg application. And this is the command. So I copy paste it from text file, and I split into the lines just to make sure that all the concepts are fairly clear. So first of all, this is the command to tell that this will be the compiler we're going to use. It is also told later, but this to remark the thing that we're going to use. This is a CL, that is the CC for the Microsoft distributions. Then we have the pkgconfig path flag, which is this pkgconfig path flag. Be careful to put everything related to this before the configure. So everything before, it's not related to the configure itself, it's something before given by the environment, given to the environment. So pkgconfig path will tell where are the pkgconfig paths and what are the pkgconfig paths. These are configuration files that avoid the person who is going to compile to tell where the libraries are. So automatically, as soon as you compile, there is this file. We changed a little, some pieces here and there, but this is to make our life easier without reporting everything related to where are the include files and where are the libraries. And that in this case, they are static. So in Windows, they are in .lib format, .lib format. So the syntax is like this. We have a pkgconfig path, all separated by underscores, equals to open quotes, then again pkgconfig path, colon, and then the folders where there are the application pkg config files. So in this case, for libx264, it will be in parent folder installed, because I remember that they are here in the installed folder. x264 libpkg config colon parent folder installed x265 libpkg config, then colon again with the last related to SDL. So underscore parent folder installed SDL libpkg configs. This is where they are. So these are the positions, the paths where there will be the pkg config files. Then finally, we have the configure. So the file that will be invoked to make the configuration for the later compiling. And then we have the so-called prefix. What is the prefix? The prefix is the position, the path, where there will be the installed applications. So as soon as we make install, all the files that will be created will be moved from the build folder, where we are now, and the installed folder. We have also the other flags. So minus toolchain will tell, hey, this will be compiled using the MSVC environment. So with all the compiler provided by Microsoft. Then minus target OS. So this is the target where we are going to compile the FFmpeg. So in this case, we want a Windows application. So Win64. If it is also available for Windows 32 bits. So in this moment, we are only compiling 64 bits. We have a processor in 64 bits. We want this to be a learning application for later. We want to debug. So we want to keep everything for the processor we are working, which is an x86_64. So make sure that you're compiling on the architecture that is suitable for you. Otherwise, you are going to cross-compile. So this is another thing that is getting a bit more complex. So make sure you're compiling in the application. So you are compiling in architecture. So be sure that the architecture corresponds to what we have here. Then we are going to disable all the assembly, so the assembler instructions. So disable -x86 ASM and disable -ASM. So these are telling, since we don't want an optimized version, which seems a bit counterintuitive, because you want an application that is faster, smaller, but in this case, we want an application that is followable within the debugger. So if you remember in an old video of mine, there wasn't this correspondence, and so we need to disable all the kinds of optimization in order to follow the instructions one by one. Then, since we want a static application, we want a shared, so we want disable the shared, and want to enable the static. So this will tell exactly this. Disable the usage of DLLs. We want a thing that is fully static. What does it mean? We have an application that contains everything. An application that will be bigger, but without DLLs around, so without calling external files from the application. Everything is inside the application. Then we are going to enable the libraries we want inside, the ones that we compiled in the previous versions, in the previous videos in the series. So we have enable libx264, enable -libx265, enable -libvpx, enable SDL2. This will be for ffplay. So we tell explicitly we want to compile ffplay. I saw also that even if you don't put it and it recognizes that there is SDL, it will compile FFmpeg as well. But we put it explicitly that we want ffplay. Then, since the compiling won't work, we are disabling the protocol RTMP, we are disabling the protocol RTMPS, we are disabling the protocol RTMPT, and also RTMPTS. So these protocols will be removed because so there were some problems while compiling. Simply as that. So if you use them, we've got to see another way. We are going to disable the documentation. So just to speed up the process, since we have the documentation somewhere else. If you want it, put it there, disable, take out this disable. Otherwise, put disable doc. It should be slightly faster because it doesn't generate the final documentation. Then we have the enable GPL, enable version 3. Why? Because we want to enable the codecs with this type of license. So the GPL is the free software license, and it has some strict things. So make sure that the code you're putting, the possible application you're going to do later, or FFmpeg itself, inside another application. So theoretically, with an application, it's fine, but putting the code inside another application, which is not GPL, is forbidden. So be careful with this licensing. Then we want to enable the debug version also. So along with FFmpeg, FFprobe, FFplay, we have also their debug versions. So we have FFmpeg _G, FFprobe _G, and FFplay _G that contains the debug symbols for these applications. Then we are disabling all the types of optimizations. This is a bit softer. This will be valid inside the compiling within FFmpeg, but MSVC doesn't understand this thing so well because it has its own pool of optimization flags. So if you put this, there's a risk that it is completely ignored, so you have an optimized application. So the thing that you should do is to put these -- opt flags, which will tell some optimization flags. So here we have the -OD, that means disable optimizations, and then -ZI is more a debug thing that tells put all the debug symbols in a separate file, that is the -PDB. Sorry, the .pdb. So along with the debug version, we have the PDB with the symbols. Then we have the thing that we avoided with the other libraries, but the only exception that we had with the pkg config is libvpx. So here, explicitly, we have to put the location where the include files and the libraries are. So in this case, --extra-c flags equals to the location where there is the include. The same thing with the C++ flags. So extra, --extra, dash, cxx flags equals to this. So we have the location that is the same as the C flags. There is no difference. And then the -mtd, capital M, capital T, lowercase d. Why? This tells, hey, compile statically in debug mode. So this is the indication that it should tell. Finally, last but not least, we have the extra LD flags. And this is the indication to tell the linker where is the library for libvpx. We could have built also a pkg config for libvpx to have everything more compliant, but just to keep everything vanilla as it comes out from the compiling in the previous step, this is what we can take. Okay, now it doesn't work. Why? Simple. We got to go inside FFmpeg. Got to get in the folder, go inside and wait for the result. Okay, so here now the process is finished. As you can see, the license will be GPL version 3 or later. And we are going a bit to the top to check which are the libraries that have been included. So we have libvpx, libx264, libx265, SDL2 that will be generating FFmpeg, ffprobe, ffplay. And just to check which are the libraries that we are going to use. So the decoder, with decoders, we don't have libx264, libx265 because these are encoders. So these are available here, libx264, libx264 RGB and libx265, along with libvpx vp8, libvpx vp9. These are the ones that we wanted. Good. So now we are ready to give the big command. And the big command is make. So very short, but very effective, that will occupy us for a very long time. So now it depends. You can take 10 minutes, 20 minutes, 40 minutes. It depends on your CPU. So I guess it's more or less 20 minutes for me. So I'm going to run make and see if there are errors and stuff. So if everything goes fine, I will have my applications ready to be used. Okay, so now everything is finished. And so we are trying to work with these applications now. Good, so far so good. If you would like right now, as soon as you are working, so I was just a bit testing to see everything, if everything was working. If you would like to get the main applications from the build to the installed, the thing that you can do is to make a make install. And once it's finished, you will see that on the installed folder FFmpeg, you have everything. So include, lib, share. But what's interesting is for us the bin where we have FFmpeg, ffplay, and ffprobe alone. So without any further DLLs. So these are for, if you want to include these somewhere else, if you want to use the applications alone, they are fully working. So if we open another terminal right here, and we are putting, for example, ffplay, you will see that this is our application, the same with FFmpeg, and also with ffprobe. So everything is working fine. At least the software is executed correctly. Okay, now it's time to test. So we have our applications that are here in the folder where we are. So FFmpeg, FFmpeg debug version, ffplay, ffplay debug version, ffprobe, ffprobe debug version. Then we have this folder, FFmpeg test videos, so-called, with an input file. So in the input folder, there's the input test file, and there's output with nothing. So we're going to fill it little by little with the new files. Especially we are concentrating on the files that are in our compiled libraries. So here, first of all, we can try already ffplay. So I have the command right here with the input test file. And here we go. So we have ffplay that is playing fine. And also we can try debug version. So here ffplay _g debug. And here we go. Here it is. Let's try also ffprobe. So we have same file, but instead of ffplay, we have ffprobe. here it says that it's a VP9 itself, so the original stream is a VP9, and also ffpro_g with the debug symbols. Okay, so we have everything fine. So far, both ffplay and ffprobe are working as they are expected. And now let's try with FFmpeg. So first file we are going to create with FFmpeg, let's say release version with the input file that we are using, with libx264 with a constant rate factor of 18, preset slow. We always copy the audio stream because at the moment we didn't touch the audio stream yet, and we are going. So let's see how it's going. So we can take a look at the output folder to see how it's going. Good, and it created the first file. We can go with ffplay, also ffprobe first, and we drag and drop the file here. And it says H264. And now we can go with ffplay. ffplay. And here we go. The video is playing fine. Good. Let's go on with the FFmpeg debug version. So we are changing this. So this will be the codec. This will be the release or debug version. Okay, and it went fine. Let's use ffprobe. Let's say G this time. I'm not saying debug, tested with debug, release, tested with release. I'm testing randomly like so. And I guess it's getting fine. So this is an MP4, video H264. Good. FFmpeg release with libx265, preset slow, CRF, constant rate factor 18. Always copy the audio stream in an MP4. Okay, so we have now our X265 release file. Let's try with ffprobe, say G, and it's working fine. So HEVC. Now let's try and play it. And it's working fine. Good. Let's try with the debug version. So create a new file, debug. Let's go. Okay, file created. Now we are going with ffprobe, say debug version this time. Let's go. It's working fine. And now ffplay. Good. Now we are trying with libvpx. So libvpx is essentially two codecs, so we try both. There's VP8 and VP9. This is the command that I'm going to use. This is for the VP8 version, so -cv libvpx. Then this is the quantizer at the minimum and the maximum that it will adjust according to the content. And then a constant rate factor that works differently than the others. So I put 18 in one and the other. Before here there is 5. So the values are different and we cannot make so much of a correspondence. Maybe we can make something in the future about what's the comparison of these constant rate factor. Okay, so let's go. Okay, and it worked fine. So just a note, I used MKV instead of MP4 because libvp8 is not supported by the MP4 container. And now let's try with a new file. It says VP8. Okay, good. And now we can try with ffplay. And also this works fine. Okay, Then now we're going with the debug version. So libvpx debug version. Okay, so let's try with ffprobe release. And also we play. Here we go. Then last but not least, we have libvpx vp9. Still, it's the same thing. Now we have as -c:\v libvpx-vp9. Okay, so now we have libvpx vp9. We are trying it. So ffprobe. We're trying with the release, just because I'm lazy and don't want to type underscores. vp9, good. And now we put ffplay. Okay. The last, so FFmpeg debug version vp9. Okay, so and finish just a word about the command itself. So this is libvpx vp9 crf constant rate factor of 30 minus bv, which tells the bit rate for the video, and that's so it's I put it as it is. I didn't mind so much about quality and stuff like that. So now ffprobe, good, and the file is this debug, and with ffprobe everything works fine. vp9, and last but not least, ffplay. Here we go. Good. So ready and fully tested. Okay, so now we finish with this giant work about compiling FFmpeg on Windows statically using the Microsoft compiler. And so now you can integrate it in Visual Studio Code or any other debugger you would like on the Windows, as we did on Linux. So then later we can go on and attaching the debugger in order to go on if you would like to follow the tutorial that I've started a while ago. Okay, so if you follow up to this point, great work, your job. So fist bump, high five, whatever you would like. So kudos to you guys. And thank you for watching above all. And if you like, please like, share, subscribe, hit the notification bell to get notified about the next videos I'll be releasing. So the usual goodbye message every YouTuber is telling. And for the moment, see you next time with other content related to multimedia, but also much, much, much more. Ciao. Ciao.